Hi everyone, thank you for your interest in mrMeshPy. I thought what I'd do is do this as a screencast rather than a definitive PDF tutorial for this stage, just maybe we can get everyone up and running, get some feedback. So what I'm going to do in the first instance is grab the VistaSoft repository. This is my fork, but I guess it will be merged by the time you guys get this. So I'm just going to download that so everything's nice and clean, fresh, all using the same version. It's going to be in place in a second. I'm going to be using MATLAB version 2017 today. I have tried it on all as far back as 2012 and also tried it for one of the 2018 versions, so it seems to work okay. Not sure what's happening here, but it seems like our internet connection suddenly died. Just what you need when you're doing a demo video. Okay, right, that's catching up. Okay, so if I go into that directory, we should see that there is now a new directory called mrMeshPy, and in there we have a whole bunch of new functions that you guys won't have seen before. What I've tried to do is kept this code base completely independent, so there are some MATLAB routines in here which have a very similar naming convention, but they would only conflict with the old mrMesh code, and so if this part of the code gets loaded, it should just override the mrMesh code, and presumably people aren't going to be using both at the same time. Okay, so the key program in here is the mrMeshPy.py program, so I'm just going to launch Python to launch that. We can do this a bit more elegantly down the road with a button in MATLAB if we need to. This is just quite handy because it'll give us a lot of debug information here if things are going wrong. Right, so that launches an application built in Qt, and this is a VTK window over here. This will become populated with a number of different tabs as we load more and more meshes in. A couple of notes here. This is using TCP protocols to send information between MATLAB and Python. I've currently just hard-coded it to port 9999, but there's no reason why we can't actually have it doing things intelligently and picking up available ports so that we can run multiple instances. That was one of the challenges with the mrMesh server as well. Okay, the program itself, very alpha at the moment, but it kind of works for the best part. But there are a few things that are still obviously in development. For example, the ROIs. Got some other routines in here, just some buttons to help me test things. But I would really see this application as a viewer. Don't think of this as something where you're going to be doing your hardcore analysis, and even the ROI drawing is still pretty experimental at the moment. We're nearly there, but I wouldn't use it for that just yet. Okay, so that's the health warning. Let's launch a MATLAB session. MATLAB 2017, 64-bit, Python 2.7 by the way. Okay, you will need Qt5 and VTK6 for this as well. Those are just downloadable packages in Ubuntu, so you should be away with that. Okay, I'm going to add that same Vista directory to my path. So that is the only Vista distribution I have in my path at the moment. I'm going to CD to somewhere where I have some data, and I'm going to start a Vista session. So I'll jump straight into the grey view here, some data that's already saved with preferences. So I'll just minimize that for the time being, just so we've got a bit of real estate here. Okay, so if you were wanting to view mesh data with mrMesh, this would be the point at which you would go to the window menu and you'd click the Open 3D window button. Sensible place, therefore, I've just put the Open mrMeshPy control window button here. That will launch something that looks pretty similar to the old one. Not that similar, but it's got a similar kind of layout. Let's just get straight into it. So what you can do is you can either build a mesh from scratch or you can load an existing mesh. So I'll load one that I've previously created that I've got stored within this structure under so for example, here's a mesh that was built back in 2015, so long before I started working on this code base. And hopefully it loads. Right, so here's a left hemisphere for this individual. And the way that's loaded in is with the default smoothing settings, and well, this one was generated by mrMesh, so there is this kind of partially smoothed representation. It's not the initial vertices, but it just uses a default set of arguments in the building of the initial mesh and the initial display. I've just used exactly the same settings here, so that should be rendered near identically to the way it's rendered in mrMesh, and those of you who can still run mrMesh might want to have a look at that and see, convince yourselves that it's true. Okay, so this is an old mesh. What I can do from this kind of baseline position, which has got some smoothing done to it already, any other operations that are done to it are relative to this position, so I can smooth it by a factor of with 10 iterations. That just smooth it slightly. By the way, if I smooth it with no iterations, it reverts back to the original vertex positions. So any operation here is always done relative to this unsmoothed state. So I'll run that now. Take a little longer. Okay, so quite a bit more smoothing on that. And that's really all there is to the smoothing algorithms. Of course, what you want to see are some nice retina toppy data rendered onto the surface, and just as it was in the mrMesh control window, we're just going to hit update, and that's going to send the data for those vertices over to this mesh, and we have a nice, hopefully what we can agree is an eccentricity map displayed on the surface. As we change our threshold here, it doesn't automatically change on the surface. We do need to hit our update button. We can think about changing these things, but my initial idea was just to keep it as similar as it was to mrMesh, purely for legacy reasons, to make it easier for people to use. So we can change those. We can switch our map to a ring representation, polar angle. I'll hit update, and that'll send those data over. So that's the left hemisphere. How about another mesh? So let's look at a mesh that was generated several years ago for the right hemisphere. We'll load that. Okay, so hopefully you'll notice a few things there. What it's done is it's loaded this mesh in. It's loaded it on a separate tab here, and the tab names here, not particularly elegant at the moment, it's something we can think about, but they are just named, they date and time stamped, so these identities here correspond to these meshes. So any operations that are performed on here, very much like the mrMesh GUI, they operate on the corresponding mesh in this namespace over here. So if we want to work on this mesh, we want to smooth it a bit, and that's now smoothed that, and we can update it, and there's some mesh data displayed for us. Okay, pretty straightforward, hopefully quite self-explanatory. Hopefully your program hasn't blown up by this point. If it does, the debug information from this window here, and indeed any debug information, I mean this is particularly verbose at the moment in these windows, but is by design, so we can capture things as they are crashing. Please send me those if things do crash, they're handy to see. Okay, so of course one of the big challenges with mrMesh was the ability to be able to build new meshes, and the challenges that posed because they all build VTK4 builds. So we're now away from that. We're using essentially an identical algorithm with the just more modern code that we can compile, and should be maintainable moving forward. So what we want to do now, a little mrMeshPy window. I'll just again minimize things a bit. Okay, so we want to build a new mesh. So for the right hemisphere, for argument's sake. So hopefully what you can notice here is I've actually kept the kind of processing stream is again just the same as mrMesh was. It's just these same sequential windows. You get exactly the same interface actually, because the processing is essentially identical. It's just a new implementation of the code base. So you've seen these dialogues before. They ask us which hemisphere we want to use. It'll ask us in a second to confirm that that is the classification file we want to use, and then it's going to build a mesh. Now we'll get rid of this moving forward, but at the moment what I've done is I've got the program that's building the mesh to render the mesh that's been built temporarily in this pop-up window. That really is again for debug purposes, and that will allow us to make sure that we're actually getting sensible meshes in the building process. Again, with those programs running out here, the information will be useful if things are breaking. We can grab that output there. Okay, so if you've built a few meshes in your time, what you probably recognize is that this is the manifold, that this is the boundary between the grey and white matter that's actually extracted directly from the classification file for this hemisphere, hence why it looks so blocky, completely unsmooth. This is what Mr. Mesh would have called the init vertices, initial vertex set, and that looks sensible. That's a nice big contiguous blob. It's got some structure in it, and it's got these little points that we've always seen in the past. Incidentally, I've got some nice ways of dealing with that, I think. Watch the space. Right, so that looks sensible. Nothing is going to move on in for the time being until I actually close this window, and that's going to pop up another one. And this one, albeit red and yellow, the color map doesn't really mean anything. That's just telling us the curvature information. But what this does correspond to is kind of that initial set of smoothing that's done to the vertices with the same default settings that Mr. Mesh always used, which I think was something like 30 iterations with a relaxation factor of 1. So that again is just a sanity check. If that step hasn't worked, we should get some debug information in here that's going to be useful moving forward. I propose in future these, you won't even see this, they'll just happen in the background, but they're useful for now. Okay, again, things won't move forward until we actually close this. When it does, it'll do the computation between the layer connections, and then because it's generated a mesh in the Vista data format, it'll ask us if we want to save that. So for argument's sake, I'll just do that. Okay, and that dataset has been generated, it's been saved to disk, and what I now need to do is